Hi kids, we will be looking into this small thing like parallel plates, conducting parallel plates, and I will show you like what are the situations and how the charge redistribution will happen. So if there are two parallel plates which are placed close to each other, and if one plate is, these are conducting plates, and if one plate is given charge q1 and another plate is given charge q2, charges will redistribute in such a way that field in the material of the conductor is going to be 0. That's how the charges will be redistributing, right? So in the material, in the meat of the conductor has to be 0. Now for that I don't know how the charges are going to redistribute, but I can clearly show you, like when the plates are placed close to each other, there is no big difference between this point and this point. So they are like symmetrical situation kind of thing. So from there I can show you like the field has to be like only like perpendicular to the plate, especially in the middle, not about the end. There will always be fringe effect in the end, but I am talking about the middle. And that's how we will be dealing things also. So if I take a Gaussian surface, now Gaussian cylinder, where one base of the cylinder is in the conductor, one base of the cylinder is inside the conductor, and the remaining lateral surface is like this. Now electric field inside the conductor is 0, so flux through this area is going to be 0. Electric field in the conductor is 0, so flux through this one is going to be 0. And just now we have convinced ourselves by symmetry, the field lines will be perpendicular to the plate. So when you take the curved surface, the field lines will be parallel to the curved surface. So basically flux through the curved surface is also 0. So we understood total flux through the Gaussian surface is 0. So total charge enclosed must be 0. Now I can show you the same thing for other areas also. From there we can conclude if the total charge has to be 0. So the only way it can happen is one is having plus and one is having minus. Sometimes it can be 0 also, but the general solution is going to be plus positive charge or negative charge. So the overall charge on this side plus this side has to be 0. I am assuming this face has charge A, this face has, so then this face will be having minus A. Now I don't know what is the charge on this face, so I am assuming it as X. What is the charge on this face? I don't know, I am calling it as Y. There are two plates, so 4 faces. Out of 4 faces, these two are equal and opposite. I have proved by using Gauss law, and I am assuming this side charge is X, this side charge is Y, right? Now if I want to find the field here will be because of 4 charges. One is X, one is plus A, one is minus A, one is plus Y. Now I can show you field here because of A will be in this direction, field because of minus A will be in this direction, and they will be equal and opposite. So they will be getting cancelled. So field because of this plus A and this minus A is 0 here. Field because of this X will be in this direction, field because of this Y will be in this direction. But we know the net has to be 0. The only way net can become 0 is when X equals to Y. See, I am not talking about formula of field due to sheet. Field due to sheet is sigma by 2 epsilon naught. Anyway, so that you can manage. So field due to this one will be in this direction, field due to this one will be in this direction. If they have to get cancelled, the only way is X equals to Y. So from there I can conclude X equals to Y. Now apart from that, what is the total charge? Total charge, this plus this plus this plus this. Now you can see this plus this is 0. So total charge is X plus Y. X plus Y equals to total charge Q1 plus Q2. So I understood X equals to Y by making field in the conductor 0. X plus Y equals to Q1 plus Q2 by charge conservation. Now when you solve for this, you will get X equals to Y equals to Q1 plus Q2 by 2. Right? Now that's kind of general result, like outside charge will be half of total charge. So anyway, so we will be going for general situation itself. Anyway, before that, what we understood, outside charge is going to be Q1 plus Q2 by 2, Q1 plus Q2 by 2. Now if outside charge is Q1 plus Q2 by 2, out of Q1, this much thing is here, so the remaining will be here. The summation of these two must be equals to Q1 by charge conservation. So this one we understood. So this plus this must be giving you Q2. So charges will be redistributing this way. This looks little bad with numbers, you will understand little better. Anyway, we will derive it for general thing. So if there are 6 plates and charge given is Q1, Q2, Q3, Q4, Q5, Q6, again I can show you these two will be equal and opposite by taking Gaussian surface. See, these plates are placed close to each other. I have just drawn them separately for fitting the information. So these two will be equal and opposite, equal and opposite, equal and opposite, equal and opposite, equal and opposite. And outside charges I don't know, so I am calling it as X and Y. Again I can show you outside charges will be equal by taking the field here to be 0. Field because of these two will be 0 here, field because of these two will be 0 here, field because of these two will be 0, field because of these two will be 0, field because of these two will be 0. Now field because of this one will be in this direction, field because of this one will be in this direction. If the net has to be 0, the only way it can be 0 is when X equals to Y. So again we understood X equals to Y. And again, what is the total charge? This charge is 0, this charge is 0, 0, 0, 0. So total charge is X plus Y again. So again X equals to Y and total charge is x plus y is total charge. Again, when I solve for this, I will get x equals to y equals to half of the total charge. So from here we understood, if we know the total charge, outside plates will have half of the total charge. Now again, with numbers it looks much better, so let me show you with the numbers. So if this charge is 12, 12, 12, 6, 6, 6, then 36 plus 18, 54. Total charge is 54, so outside charges will be half of 54, 27 and 27. So let me start from here. If this is 27, this has to be minus 15 such that the total will be 12. If this is minus 15, this will be plus 15, I can show you by Gauss law. If this is plus 15, this will be minus 3, so that the total will be 12. If this is minus 3, this will be plus 3, I can prove you by Gauss law. If this is plus 3, this will be 9, charge has to be conserved. If this is 9, this will be minus 9 by Gauss law. If this is minus 9, this will be 15 because of charge conservation. If this is plus 15, this will be minus 15 because of Gauss law. If this is minus 15, this will be 21 by charge conservation. If this is 21, this will be minus 21 by Gauss law. Now you can even cross check, the summation is going to be 6, right? Now what will happen if one of the end plate is grounded? If one of the end plate is grounded, there are many things here. First of all, I am going to show you outside charge is going to be 0. Now in order to show that, let me assume it is not 0. Let me say there is some positive charge. If there is some positive charge, the field lines emerging will be going to infinity, because you know these two are equal and opposite. Whatever field lines emerging from here, they will be ending here. These field lines will be restricted in this region, restricted in this region, restricted in this region. So, and anyway, you know outside charges have to be equal also. So if there is positive charge here, there will be positive charge here also. They can't really end here. So this field lines will be going to infinity. Suppose if there is positive charge, this field lines will be emerging and going to infinity. So when you take a positive charge, when you take a unit positive charge along the field line, what should be happening? Electric field should be doing work, but you know potential here is 0, potential at infinity is also 0. So the meaning is electric field shouldn't do any work when you take a positive charge from here to there. The only way it can happen is electric field lines shouldn't be present. That is, whatever our assumption is wrong. So we assumed electric field lines are there. So when you assume that, when you are taking a unit charge from here to infinity, electric field is doing work, so potential difference must happen, but potential difference is not there in the first place. So our assumption is wrong. There won't be any charge on this side, so it will be 0. Now once you know this is 0, you can easily say this is going to be 0 because field here has to be 0. Field due to these two will get cancelled, equal and opposite, right? So field outside charges anyway have to be equal. Once you understand this is 0, then this is also going to be 0, because grounding in the sense potential is 0, right? So if this potential has to be 0, and if infinity potential is 0, the only way it can is when there are no field lines from here to infinity. Now once you understand this is 0, here charge can't be conserved. Though you have given 6, ground can give the charge, so we can't really start from here, so we'll start from here. So outside charge is 0, so inside will be 12 by charge conservation. If this is 12, this will be minus 12 by Gauss law. If this is minus 12, this will be 24 by charge conservation. If this is 24, this will be minus 24 by Gauss law. Minus 24, this is 36 by charge conservation. Plus 36 minus 36 by Gauss law. 42 by charge conservation, minus 42 by Gauss law. 48 by charge conservation, minus 48 by Gauss law. So basically it need not be 6, because ground can give the charge or take the charge, right? Now what will happen if this plate is grounded? Again I can go with the same argument. If this plate is grounded, I can show you this charge is going to be 0. If this charge is 0, then this charge is also going to be 0. But charge on this plate need not be 12, ground can give or take the charge. So we'll start from here. This is 0. By charge conservation, this will be plus 6. By Gauss law, this will be minus 6. By charge conservation, this will be 12. By Gauss law, this will be minus 12. By charge conservation, 18. By Gauss law, minus 18. By charge conservation, 30. By Gauss law, minus 30. By charge conservation, 42. By Gauss law, minus 42. So basically earlier we have given 12, but now it is minus 42. So ground has done its stuff, right? Thank you.